All right, we're back with example 3, discussing the law of syllogism. So just like we just talked about the law of detachment, right? And there were specific rules for the law of detachment. There are specific rules for the law of syllogism too. There's going to be these step-by-step rules, and for it to be valid by the law of syllogism, it has to follow those rules. If it deviates from those rules at all, then it is not valid by the law of syllogism. So the only way that you can do these problems if you know the rules, okay? So you have to memorize them. So this is going to be our flashcard here, the law of syllogism. So make sure you study both of these. You are capable of being able to do this, but you have to put in time, you have to put in effort, you got to put in dedication to know the law of syllogism and to know the law of detachment and to be able to see how they're different or how they're the same, right? So you can differentiate between, you look at something, oh, that's the law of detachment, or you look at something else, oh, that's the law of syllogism, okay? So let's look at this first. It says, if P to Q and Q to R are true statements, so you have two conditionals, then P to R is a true statement, okay? So there's a lot written in these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 words, okay? There's a lot going on here, and I'm going to try to decode it for you so you understand what this is saying. So it's saying if P to Q and Q to R are true statements, then P to R is a true statement. That is the law of syllogism. Okay. So, the first thing, what we're going to have, it says if P to Q and Q to R are true statements. So what that tells you is you're going to have, this is a conditional statement here. This is our first conditional statement. And then we're going to have a second conditional statement. Okay, that is different than the law of detachment. We did not have two conditional statements. We had one conditional statement, and then the next sentence only talked about the hypothesis. If you look here in the World Series, if a team wins the 4 games, then the team wins the series. Okay, that is a conditional statement. The Red Sox won 4 games in the World Series. That is only talking about the hypothesis. The next sentence is only talking about the conclusion. The Red Sox won. Okay, so there's 3 sentences, but only the first sentence is a conditional where it has those if and then words. Second sentence, only the hypothesis. Third sentence, only the conclusion. The law of syllogism is different. Okay, you not only have a conditional statement as the first sentence, the second sentence is also a conditional statement. Then it says, then P to R is a true statement. So this is our third conditional statement. Conditional statement. So we have 1, 2, 3. So you have if P, then Q. Then you're going to have if Q, then R. Then you would say, then if P, then R. Okay, so there's 3 conditional statements. When you're reading through this, okay, and the third one, this one's going to be the conjecture, right? This is the conjecture. So just like the law of detachment, we had 2 sentences. And then we had our conjecture, which was the third, okay? But the difference is we had a if P, then Q, and then we had P, and then the conjecture was only about the Q. Law of syllogism, different, okay? We're going to have a conditional the first sentence. We're going to have a conditional the second sentence, and then our conjecture is going to be a conditional. So 3, 1, 2, 3, conditionals. Law of syllogism, all about conditional statements. If P, then Q. That's the first thing you need to realize. The second thing you need to realize is this right here. It says, if P, then Q, okay? So this Q is our conclusion right there. But for this to be the pattern of the law of syllogism, I shouldn't say the word pattern because that goes back to inductive reasoning. So I'll say the rule. The rule of the law of syllogism, means that that first sentence where that Q is the hypothesis, the second sentence, that Q that was the hypothesis, then becomes the hypothesis. It becomes the first thing in the second sentence. All right? So basically it's saying, okay, if P, then Q, and if Q, then R, then basically we can say if P, then R. Okay, that's what it's saying. So let's look at this and see if that's true. I know that's a lot of information, so let's look at some different examples, and you may have to look at the examples and then go back and hear me explain that again after we've looked at it, a few examples, and then it will probably, hopefully, make more sense to you. Okay, so it says, the first part, if a figure is a kite, then it is a quadrilateral. If a figure is a quadrilateral, then it is a polygon. Conjecture, if a figure is a kite, then it is a polygon. So the first question I'm asking myself is, do I have three conditionals? If a figure is a kite, then it is a quadrilateral. Okay, that's conditional statement number one. If a figure is a quadrilateral, then it is a polygon. Okay, that's conditional statement number two. And then finally, our conjecture should be a conditional statement. If a figure is a kite, then it is a polygon. Okay, there's three conditionals. So since there's three conditional statements, I know that I'm dealing with the law of syllogism. Okay? Now what we need to do is we need to define our terms, P, Q, and R. See, P, Q, and R, okay? So our first sentence, for the most part, and I said for the most part, okay, that doesn't mean always, okay, but for the most part, the first sentence is going to give our P and our Q. If a figure is a kite, then it is a quadrilateral. Okay, so a figure is a kite, that's going to be my P, all right? It is a quadrilateral, that's going to be my Q. So a figure is a kite, and I need to define these. So on your homework problems, quizzes, tests, you need to define those first. A figure is a kite, then it is a quadrilateral. Well, what is it? A figure. So we'd say a quadrilateral, a figure is a quadrilateral. Okay? That's our first P to Q. So our first statement is a P to Q. Okay? And that's true. If a figure is a kite, right, it is a quadrilateral. Quadrilateral just means it's a four-sided figure. Okay, and you know a kite has two sides like that are equal, and then these two are the same. That's what a kite is. And it's so it's a four-sided figure, quadrilateral. Yeah. So then let's go to the second sentence. Now, remember, the second sentence must start with the conclusion, right? Does the second sentence start with a figure is a quadrilateral? Because that's what it needs to follow these rules of the law of syllogism. The second sentence must start with the conclusion of the first sentence. So we need it to start with a figure is a quadrilateral. Let's read it. So we have this. If a figure is a quadrilateral, boom, perfect. So that's exactly what we need. We needed, if a figure is a kite, then it is a quadrilateral. So this is our Q, right? If a figure is a quadrilateral, this has to be our Q. So it has to be like sandwich. The Q's have to be sandwich. The Q has to be at the end of the sentence here, and then the beginning of the second sentence here. Okay? Okay, perfect. Okay, so yeah. So we're in the second sentence, Q to R. And notice this R, that's something different, right? P to Q, Q, okay, P to Q, and then Q, that's the same. But R is different, so that means the information has to be different. Then it is a polygon. Okay, well, that's different information. It's not referring to the kite, and it's not referring to the quadrilateral. So that is our R. It is a polygon. Well, what is a polygon? The figure is a polygon. And a polygon is just a shape with many sides. So we have our first sentence, which was our P to Q. And then our second sentence had to start with the Q, and it did, which is great. And then we got to the R. So that's our second sentence. P to R. So the conjecture for this to be this law of syllogism, no, this is Q. I'm sorry, this is supposed to be Q to R. Ugh. I hate when I mess up. So the first sentence is P to Q. The second sentence must be Q to R, which means that the third sentence must be P to R. If a figure is a kite, then a figure is a polygon. Okay? Is that what we have? Conjecture. If a figure is a kite, that is our P. Then it is a polygon, which is our R. Okay? So that's our third. It fits, so this is valid by the law of syllogism. It exactly fits the law of syllogism. So yes. The conjecture is valid by the law of syllogism because our first sentence is P to Q, and then our second sentence is Q to R. Therefore, P to R must be true, must be valid, or be true, valid, same thing. Okay? So that is our answer. Okay, for this problem. That is the law of syllogism. Okay, so like I said, flashcard. Flashcard, flashcard, flashcard. All right. Let's go ahead and look at the second one. This second problem states, if a number is divisible by 2, then it is even. If a number is even, then it is an integer. Conjecture, if a number is an integer, then it is divisible by 2. Okay, so let's break this down. First off, we need 3 conditional statements, right? So if a number is divisible by 2, then it is even. Okay, that's a conditional. If a number is even, then it is an integer. That's number 2. Number 2 as far as conditional statements. Conjecture, if a number is an integer, then it is divisible by 3. Okay, that's our third conditional statement. So boom, we know that we're in the realm of law of syllogism. We have 3 conditional statements. So now we have to see, okay, does it follow these rules? Is the first sentence P to Q? Is the second sentence Q to R? And then is the third sentence P to R? So here we go. If a number is divisible by 2, then it is even. Okay? And then if it is even, then it is an integer. So remember, we need the P to Q, right? But the key thing is that that Q is then the beginning of the second sentence. So do we have that? Then it is even. This would be our P, this would be our Q. Is this Q? If a number's even. Yes, it is. That's the start. So it ends the first sentence, and that ending of the first sentence must start the beginning of the second sentence. And it's true, right? So let's go ahead and write down what our P, Q, and R are. So if a number is divisible by 2, that's going to be our P. So a number is divisible by 2. Then it is even. So we would say a number is even. That's our Q. A number is even. And then, okay, so P, Q. Q, is this different? Yes, it is an integer. So a number is an integer. Okay, so our first sentence is P to Q. That works. Our second sentence is Q to R, which works. So that means our third sentence must be P to R. If P, then R. So it should say, if a number is divisible by 2, then it is an integer. Is that what this says? If a number is an integer. Oh, that is our R. Then it is divisible by 2, which is our P. So this statement is supposed to be P to R, conjecture, but what this is this is if R to P. This is R to P, so this is backwards. So this does not fit the rule. This does, but this doesn't. This example is R to P when it's supposed to be P to R. So because of that, we cannot, it's not valid by the law of syllogism. It doesn't fit the rules. So the question is, determine if the conjecture is valid by the law of syllogism. The conjecture is invalid by the law of syllogism because the conjecture is R to P when it is supposed to be P to R. Okay? So that is the reason why it is invalid. Okay, let's look at another example. Okay, this one I think is going to be a fun one. All right. Now, let me see if this, I don't know if that will help me. I need something very quickly. What can I find that will help me? Okay, here we go. Okay, so I'm going to use these sticky notes right here. Okay, and hopefully this will help. Now, remember when I said the first sentence has to be P, or I said most of the time it's P to Q. So this is going to be my first sentence. This is going to be called my first sentence. And this is going to be called my second sentence. Okay, now, so for the most part, what we have is we have P to Q, and then Q to R. So, for the most part, our first sentence under the law of syllogism, and we'll just say our conjecture here. Okay, I'll say, that doesn't look very good. Can you see that? Okay, this would be the third sentence. Oh man, third sentence. And which would be the conjecture, right? This should be P to R. Now, I'm going to try to give you hopefully a visual aid, and hopefully this will help before we get to the actual problem. So, for the most part, you're going to have the P to Q and then the Q to R in the second sentence. And the third sentence is going to be the conjecture P to R, like what we've talked about, right? And what the big thing that's important is that Q is the end of the first sentence and it's the start of the second sentence. So that's really what you're looking at. Two conditional statements, right? Where the end of the first sentence is actually the beginning of the second sentence. Now, like I said most of the time that is the case. However, sometimes you may get something that is like this. Okay, you may get something like this. Where you have a conditional, right? This is a conditional, this is a conditional. Now, remember, this would be in our first sentence, right? This would look like it was in our first sentence place. And this would look like it was in our second sentence place. And so what you would be looking at is what you would be looking for is that the end of this sentence is the same as the beginning of the second sentence. Well, that is not the case here. But this is why I said most of the time, because sometimes they try to be tricky with these first two sentences, right? So this doesn't look like it fits because this end, even though we have two conditionals, this end of the first sentence is not the beginning of the second sentence, which is what you need. However, they're being tricky because if you took these sentences and all you did was made your second sentence the first sentence and the first sentence the second sentence, like this, and you just switch the order, then you would have the end of the first sentence becoming the beginning of the second, which is what you need for the law of syllogism. So that's the tricky part of the law of syllogism. For the most part, it's like this. But sometimes, once in a while, they'll try to be tricky and they'll make it look like this, where the first sentence, the end of it, does not look like the beginning of the second sentence. So when you see something like this, before you say, oh, this does not fit the rules of the law of syllogism, therefore it's invalid, what you want to do is you want to take these sentences and you want to swap them and make the second sentence into your first and the first sentence into your second, and then see if that conclusion turns into the hypothesis of the first. Okay? So, with that said, let's go ahead and look at this particular example here. It says, determine if the conjecture is valid by the law of syllogism. And this is X, Y, and Z, and I just want you to cross that out. And we're going to make this P, Q, and R. All right? So it says, if an animal is a mammal, then it has hair. If an animal is a dog, then it is a mammal. Can you see that? Let me see here. Can you even see it? Okay, now you can. Okay. If an animal is a mammal, then it has hair. If an animal is a dog, then it is a mammal. If an animal is a dog, then it has hair. Okay, perfect. So the first thing, do we have three conditional statements? If, then, that's the first one. If, then, that's the second. If, then, that's the third. Okay, we have three conditional statements. Perfect. Now what we need to do is we need to make sure that that first one is a P to Q. Okay, so if an animal is a mammal, that would be our P, then it has hair, that would be our Q, right? So it needs to be P to Q, but that would be our first sentence, but that second sentence has to start with Q, which would be here. It has hair, an animal has hair. Does this start with an animal has hair? If an animal is a dog, oh, that is not an animal having hair. So therefore, what we would do is we would say, oh wait, this does not fit the pattern of the law of syllogism, but oh wait, we have to remember this, right? Right, this is where we're at. We want this, but we have to remember sometimes the second sentence might be the first, and the first sentence might be the second. Okay, so all we have to do is we might have to swap them. Okay, make the second sentence our first sentence. So let's try to do that. We're going to look at this. Okay, so we know that it doesn't work in this order right now, but before we say it is invalid, what we want to do is we want to swap these two sentences and see if we can make it work that way. So let's start with the second sentence. If an animal is a dog, then it is a mammal. Okay, so this would be my P, an animal is a dog, and my Q would be it is a mammal. Okay, so this would be my P, and this would be my Q here. All right, so if that's my P and this is my Q, then the first sentence would have to start with an animal is a mammal. Does this start with an animal is a mammal? It does. This starts with my Q, which would then make this, then it has air, that would be my R. Okay, so this is one of those examples where we just had to flip the order of the sentence. We have to make this second sentence our first and make the first sentence our second, and then it fits, because if an animal is a dog, that's our P, that's our Q. It ends with Q and starts with Q here. So boom, we got it. So we have to define our variables. Okay, our P is if an animal is a dog. So an animal is a dog. Then our Q is an animal is a mammal. And then our R would be an animal has hair. All right, perfect. So, okay, we've defined our terms. We know that we have our P to Q and our Q to R statement. They're just swapped. Now this has to be, this was Q to R. Our third conjecture must be P to R. Now, is this P to R? So look here. It must be if an animal is a dog, then an animal has hair. Is that the case here? If an animal is a dog. If an animal has a dog, then it has hair. Yes, this is P here, and this is R. So boom, this fits the law of syllogism. It's not, you know, the first two sentences are flip-flopped, right? But it still fits the law of syllogism. So we can say the conjecture is valid by the law of syllogism because P to Q and Q to R are true. Therefore, P to R is equal to being true or valid. So this is our entire answer right here. So you would write all of that right there. Okay? So if you are missing any of this, you will not get full credit. Okay? So you have to define your terms and you have to write all of this. Yes, it's valid by the law of syllogism, and then you have to say why it's valid. All right, that is it. Make sure that you know that you can watch these videos multiple times. So if you forget the law of syllogism or the law of detachment, just go ahead and rewatch this video, and then hopefully that will quickly remind you of what the law of syllogism is. All right, see you in a little bit for example 4.